This is Alex. He's on his way to visit a place where he spent a very important summer of his life. But that was 8 years ago. He's betting he knows how to get back there. Where has that memory of how to get to this place been all these years while Alex has gone about his life? Where are our memories when we aren't using them? Things in the world enter our mind through the senses. Then they're stored inside somehow. Some have speculated that memory in the brain may work like memory in a computer, that we take in information about the world and then file it away just like it is for recollection at any time. But research has proven the computer model of memory to be misleading. The brain is always changing, and so are memories, evolving, shifting, strengthening, fading, or disappearing altogether.
Also, what differs from the computer are two major processes that the brain has that the computer doesn't have. We have emotion, and that is extremely important. So if you learn something that is important for you, emotionally charged, you're more likely to hang on to it.
Memory is much more constructive than it is a literal reproduction of the past, and is prone to error because of that.
One way to look at memory is it's a process. So first, something enters the memory system. There's a registration in what we sometimes call sensory memory.
Sensory memory is one of 3 major types of memory storage in the brain, and these 3 types are categorized by the amount of time the memory is stored for and how we interact with it. Sensory memory is the quickest. This is information you hold in your brain for just a few seconds or less.
So sensory memory is the trace of neural activity that continues, that's related to sensory events, but continues on past when the sensory event ends. And it's very, very brief. It's just the remaining activity from that stimulation of the environmental inputs. Once you start using that information, once you start manipulating that information, you start integrating different pieces of information, you select pieces of information that might be more relevant to your goals, that's working memory.
So if you think of the simplest task where you're looking for something, we take it for granted, but working memory is involved every time you look for something because you know what you're looking for, but by definition it's not there, right? So it's in your mind, there's a template that you're trying to match to the things in the world that you see. So the question is, how does this amazing maintenance process happen?
I and many others tend to think of working memory as being composed of several components. There's part of our working memory that's really devoted to dealing with words and the sound of words. Some people call that the phonological loop. It's the part of working memory, for example, you might use to remember a phone number.
Can you please give me Mickey's number? Okay, 914-310-7535. 914-310-7535.
You separate it into the area code, the first 3 numbers, the last 4 numbers. You chunk that information. You make associations with things that you remember from long-term memory. You may have a fixed set of area codes that you're very familiar with, but then you rehearse it.
Most people can remember about 7 things, give or take 2. So a phone number, you can remember about 7 digits pretty easily, and actually the lore is that that's why phone numbers are about the length that they are. They're right in the sweet spot where just about anybody can remember them, at least over a short duration.
75 7535.
Another part of working memory is more for kind of visual and spatial information.
I just passed the Baldwin sign. It's like a and then there's the stop sign right after that.
Using this other part of memory that is often called the visuospatial sketchpad, because it's specialized for visual spatial information, for holding that information just for a few seconds.
All right, I'm gonna pass the monument on my right. For the monument, what does it look like? Oh, okay, it's got an eagle on top. The underpass. Okay, monument on the right, underpass, then church on the left. What color is the church? White.
And then there's another part of working memory that is sometimes referred to as the central executive. And that's kind of a general mental workspace where it can interface or interact with the visual spatial sketchpad and the phonological loop. So it's more of a general purpose workspace where you can bring strategies online involved in controlling the flow of information in and out of memory, things of that sort. So working memory sounds simple, but it's got these several components, and it's a very important part of the memory system.
And if you process it sufficiently, then you can get it into what is sometimes called long-term memory.
Information from short-term memory can be encoded to form long-term memories through a process called consolidation. It is through this process that the information we collect in our short-term storage throughout the day is sorted into irrelevant material ready to be forgotten, or salient important information which makes it into long-term storage. Long-term memories are distributed throughout the brain and are not static or fixed entities.
So that the next time you cue that phone number, that pattern of activity is going to be easier to reinstate, bring it back from long-term brain structure into an active pattern of activity.
When we think about the brain and the storage of long-term memory, we have to make an important distinction between two kinds of memory. One is explicit memory, sometimes as declarative memory.
Explicit is what you commonly think of as memory. It's the conscious recall of facts and events, the conscious recall of information about people, places, and objects.
And one part of the brain seems to be very important for storing these new explicit, conscious, declarative memories, and that's a part of the brain called the hippocampus, which is deep inside the temporal lobe of the brain. And the hippocampus and a couple of other structures nearby it are necessary in order to kind of transform memories from short-term working memories into long-term persisting memories.
Once that information is consolidated in long-term memory, it's independent of the hippocampus. You can have a lesion to the medial temporal lobe and still be able to recall that information. At that point, it's been encoded in structural changes in the cortex.
Yeah, implicit memory contrasts to explicit memory in that it's a kind of memory that is not consciously accessible to us. It's a kind of memory that may affect our performance, our behavior, but we're not consciously aware that we have it.
So for example, if I ask you to fill in the blanks, I want a 6-letter word, and the first 3 letters are H-A-M. If I just do it cold, somebody might say hammer. But if I earlier exposed them to the idea of Shakespeare, now when I say, give me a 6-letter word, starts with H-A-M, they might say Hamlet. Well, that shows they were influenced by the exposure to Shakespeare, and out came this word that they wouldn't have been likely to have produced otherwise, but it's connected to a concept that they were exposed to. That's implicit, an example of implicit memory.
Be it implicit or explicit memory, the path from short-term storage to long-term storage is not one way. For example, a long-term memory of a childhood baseball game is brought to present awareness.
I used to play there.
It then goes through a process called reconsolidation, where it is stored once again, but now with updated meanings and perhaps a new set of emotional charges from the present.
When you recall the memory in a new context, you sometimes incorporate aspects of that context into the memory storage. So this can distort the memory that you have.
Especially over time, as we continue to think about them and we re-encode them, and they may get distorted over time.
And that's what produces sometimes a false memory.
Emotionally charged or shocking experiences mean stronger and more vivid memories. Flashbulb memories are those moments we'll never forget, those of tragedy, joy, or near misses. While flashbulb memories may be largely accurate, of course, nothing is perfect. Research has shown that these memories are vivid, but they can also change over time.
Hearing about the attack, the 9/11 attack on the World Trade Center and the Pentagon, for example, these highly significant events are thought to be associated with an unusual kind of memory where people can often tell you where they were and all kinds of details, where they were when they learned about the event.
For all types of memory, insights from neuroscience continue to pinpoint certain regions involved in memory processing, such as the prefrontal cortex, which has been implicated as a hub for working memory. In addition to larger regions, researchers seek to understand memory on the cellular level.
Short-term memory involves a functional change in how neurons communicate with each other. That side of communication is called the synapse. It's a functional change in the synapse. And long-term memory involves an anatomical change, a growth in new synaptic connections. And in both forms of learning, in implicit and explicit, the reason you have an anatomical change with long-term memory is you actually turn on expression of genes in the brain that gives rise to gene products, messenger RNAs, and proteins that are required for the growth of new synaptic connections.
It's these small changes at the synapse that underlie the more complex functions of millions of neurons working together in synchrony to store and retrieve memory.
Memory really defines who we are. There's a very tight connection between memory and our sense of self, so if we want to understand who we are, we need to better understand memory.
Since memory is central to mind, and our understanding of mind is just at the very beginning, there's a huge amount of work that needs to be done.